Hello, in this video, we will introduce quicksort. Quicksort works as follows. The algorithm selects an element called the pivot. It divides the array into two parts using the pivot. So the elements in the first part are less than or equal to the pivot, and all the elements in the second part are greater than the pivot. The quicksort is then recursively applied to the first part and the second part. Let's look at this example here. We're going to use this pivot 5 to partition the list into now two parts. So put the 5 here. All the numbers on the left is less than or equal to 5, and on the right is greater than 5. So 5 is in the right location now. This 5 is right here, is in the correct location. So now you can apply recursively using the quicksort to sort the first half and the second half. Now, how do you perform partition? To perform partition, we use the index low and high to denote this is in the first part and this is in the second part. So look at the pivot now. You compare this 2 with the pivot. 2 is less than 5, so this will stay here. And now move low to the next. Now 9 is greater than 5, so you now wait. And now come to the high. So high here, and compare it with pivot, is less than 5 is greater than 7, so move high to the next, and 6 is greater than 1. All right, stay right here. Swap 1 with 9, and then continue the same thing, and to go with low and to find the next number, which is greater than the pivot, and then high to find the next number, which is less than pivot. So right here, 0 and 8, swap those 2, and now continue. And now until now, you see this low and high clause. High is before low. In that case, you're going to swap this number at high with pivot. So this is right here. This is the way we perform partition, and the time complexity is order of n. So every time and you make a comparison, you're going to move either low or high. And let's look at the complete program. It's right here. It is here. You're going to have this quicksort for the array of int, and using this quicksort and the list, and here's low and high. So this quicksort is going to be called recursively. Look at the last and the first here. So that's a low and high. And if the last is greater than first, and now you get the pivot, we choose the, and this is what we do. We use a partition and partition the list, and using this first partition the list. So this is the list we're going to partition, and we're going to return and the index of the pivot after the partition. And so apply quicksort in this, and here it's the first one, and this is the low, and here this is the high. and for the first part, and this is for the second part, and this is the list, and here is the low and high of the second part. And this is the partition and how you perform the partition, implement it. Now let's look at the time complexity for quicksort. To partition an array of n elements, it takes n-1 comparisons. And n moves in the worst case. So the time required for partition is order of n. And now, in the worst case, each time the pivot divides the array into one big subarray and with the other empty. So if that's the case, and this is the end up with the worst case. And so every time, so you have one side, so n-1 elements, n-2 elements, and so all of this, and see the maximum you add together, it's order of n squared time. The best case is each time the pivot divides the array into two parts of about the same size. Let Tn denote the time required for sorting an array of elements using quicksort. So this is what you have, this Tn, and equals this. The array is divided into two parts using the partition, using the pivot to partition it. So now there's two parts are about the same size. And so this Tn divided by 2 plus Tn divided by 2. So now plus this is the time for the partition. And so this is the recurrence relationship. And for Tn to solve it, it is order of n log n. Now, the worst case and the best case, they're not representative. The average case is what we're looking for. On average, each time the pivot will not divide the array into two parts of the same size, nor one empty part. Statistically, the sizes of the two parts are very close. So the average time is order of n log n. The exact average case analysis is beyond the scope of this book. So, but this is something assured. This is very good. This is why it's called quicksort. Now, comparing with merge sort, quicksort has this benefit is once you put the pivot in the right place, you use the pivot to partition the list, you put the pivot in the right place, and you never change it. So when you sort all these things, everything here, you only need the original array. You don't have to introduce another array in the sort. For the merge sort, when you merge two sublists, you have to have a new array. So this specifies quicksort is better. That's all for this video. Thank you for watching. See you on the next video.